So, welcome to the final exercise of this foundation course. In this example, I do not initially plan to model this thing from the scratch to finish. It's going to take too long. But my main goal here is to bring you into a real-world scale project and make you see how to encounter such problems in the modeling. I will be choosing the most problematic parts of this robotic arm and show you how I made the changes or how I got to the place where I felt it was the exact same thing I want. In this order, I'm actually going to divide the model into different parts and start off from the more simple ones to the more complex ones, to both be able to review what you have learned and also encounter with some new situations that you can learn from. I'm going to be showing you how to model these details, or for example, in this part, I'm going to be showing you how to model this details in the corner. Let me show you by zooming in and rotating. I'm going to show you how to model this part. I'm going to actually be modeling everything on a very basic base mesh. Also, this part, as you can see, these are the parts where some cables will be connecting to here. Or for example, the model that we have here, how to model this thing. You see the shading here, and it's also a cable plug and some parameters or models that are going to be more complex in terms of shape, in terms of forms, and in terms of the topology. I assure you, if you take this comprehensively and not just go through it step by step, you will be able to use these principles and these situations and imagine new possibilities and do whatever might be the best in your situation you're dealing with. And now, let me show you the first section that I'm going to work on. You actually see how simple it looks, and I want to basically show you how I modeled this and gave this the sharpness, and how I used the basic principles that we've been working all around on simple planes into a geometry that is no longer primitive. In addition, I already have my base mesh here because our focus is not how to come up with a base mesh that can be used, but rather to come up with how we can apply hard surface standards to it. Let's get to the first example. So let me orbit around and show you. We still, as you can see, we have just a simple mesh without anything applied. So I turn on Turbo Smooth, and you see how it looks weirdly smooth without any detail, without any sharpness. And let's get started to do this. Generally, I have this habit of when I want to add a detail, any type of detail, when I want to add a detail to my mesh, I create another edit poly because I want to have the opportunity to just undo what I've done for the past couple of operations. Beginning with observations, if I turn on Turbo Smooth, you can see how distorted it looks. This specifically means that we have something here that is not being correctly welded together. I believe it should be this one, and yes. And so I select the weld command. You know that in previous parts we said whenever we want to sharpen the mesh that we already have, we use Swift Loop command and limit the corner edges that we have by adding some edge loops around the corners of the mesh. And so in this way, it comes all the way across the edge, but here. There's a point here. We want also the same sharpness to be applied also on these parts, these curves that you see here. But as soon as we want to add edge loop here, let me just add one here. And you already see it doesn't extend over the right side. It doesn't extend correctly on the left side. You see how it just extended when just completely on its own. The thing is, we should not just freak out. Let's continue adding the loop. One here and another one where it's being left off. And I will just show you how redirect the edges that we have on this curved and wavy surface. So the first step to do is to select the two edge loops that we added and just connect them to each other using the cut command. And so we have an edge loop surrounding the mesh we want. And now the next step is to select the unnecessary edges and just control remove the vertices or the edges that we don't need, and the same about this one. And just pay attention, we have two close vertices that cause artifacts and problems. So with target weld tool, I just connect the two edges there to make it like this. In this order, now we have both the edge that we want, and we have successfully deleted the ones that are not necessary, and also we have avoided the edges or close vertices that cause problems. And then on the other side, there's exactly the same thing going on here. Our edge just is disappearing and floating off, and we need to adjust things. First of all, we should pay attention that if we delete this edge loop here, we lose a lot of details. So instead, I add another swift loop to preserve the main shape that we have here, and then start to manually adjust the vertices and slide them near the edge that we want. And then, as before, I cut them in to the place that is in our desire. Next step, as before, is to prevent these close vertices and edges. But instead of deleting, which results in our model's deformation, we can redirect the edge loops and put the vertices in the right position, and also delete the unnecessary part. So I deselect and just control remove. Now, as you see here, I will just target weld the vertex to the wanted part, and as you can see, so smooth, and better say so sharp, we have exactly the type of mesh and the type of smoothness that we want. And now let's just move to another example. The second one is going to be the upper part of our robotic arm. This is also very simple to model, that I'm going to just sharpen the corners. And generally, let me say, generally the key part in the modeling hard surface things is to get clean base mesh with a sufficient poly count number that will be so easy and so good for us to work with. And we can just pick up our Swift Loop tool and begin to sharpen the edges and be able to adjust the vertices so easy without getting so overwhelmed by the amount of geometry. And as you can see, currently I'm dealing with the same type of problem I had before. Added the edge loops, selected the unnecessary parts, connected where I had to, and now I'm just rotating and observing the different parts of the mesh to add the possible adjustments and control remove, and then replace the edge here. And also I want to remove this one and place it ever so slightly closer to the edge. And now I apply the turbo, and as you can see, we are getting the kind of nice shading that we've been looking for. So the next part of our modeling will take actually some more time, and it's going about this one. We have this little detail that we have here. We have a edged corner and we have a soft edged corner that blends into the other parts. Now let me quickly change to my base mesh for this demonstration. A quick note to remember, just create another brand new edit poly to make things redoable. So then I am just observing the places where there's a need to add an edge loop. Let me look around here. Same goes for these parts. And I'm pretty sure that we will encounter some places that, like other examples, we need to, like here, for example, we need to manually pick our connect tools or other commands to manually connect. And here I can maybe just apply a little bit of adjustment to apply a proper distance between the edges, not for them to get jaggy and all. So let's see what we got in this L looking shape here. We know what to do here. I add the edge loop and then pick up my cut command and then like this, and try to connect my edges to the other side. But here, as you might have guessed, I add the diagonal edge to maintain the curve because we want a curve after the turbo smooth, and just quickly using the target weld tool, I connect the vertices to each other. If we now trace this edge to the other side, we will see the same thing basically here. We have two vertices that are super close to each other. We will just come back later and then Swift loop here and then connect the two with my, connect command. And now I pick up the target weld tool and just like that, I connect the vertices. Now let me observe the turbo smooth modifier. This is looking good. Let me zoom. Yeah, I think it's looking pretty good. But here, do you see how soft the transition here is? I just can give it more definition by adding another Swift loop here and make it a sharper transition, as now we can clearly see this, that there's not much softness in here. So now let us start to make that detail that we talked about and I showed to you. The first step is to just the first step here is to adjust these vertices and think about the process that we are going to apply on the base mesh that we have. Also, I need another edge, particularly in the middle, so I will just deselect that one and control remove the rest of that. And you might ask, so what is the purpose of adding only this loop? And I'm going to adjust it a little bit, and I'm going to use this edge to both act as the limit of our extrusion and also for the softness in the details. So now I think you remember how this process should be done. I select the faces and then extrude inwards for an amount. Let me just try to find the suitable amount like this. And then I have to select these vertices and snap them to the other ones. Now I just adjust a little bit. I want to make it like this, be a nice coherent angle, and then I turn on turbo smooth and you see how it is actually responding very well, but it doesn't necessarily match up with the result we want. So I go in there and start to apply some adjustments. So first of all, I pick up one edge here, one here, one in the other side. And so you remember that we will be applying some adjustments to here so that we do not get the extra edges all around the mesh with these diagonal lines. And then I'm going to select these edges, control remove, and pick up the target weld tool and weld these vertices here, and maybe delete the other edges right there to get a clean topology. So you now know the process. First you add the edge loops, then you connect the edges that you want, and then you delete the unnecessary edges, and finally apply the adjustments like target welding some vertices and just putting the verts together. So you can see it's no longer the soft shaded detail that we had, and we have applied some sharpness, but we can even, let me change the constraints to the proper one, and we can give it more depth. This only, can be done according to your reference or according to your will. But here we have also some things to do for these parts. You see we have applied a diagonal edge to there for it to be perfectly in line with turbo smooth, and also for that matter we have to do the same thing like this with cut tool. And same thing, I will just repeat the same process for here, and Let us observe. Now this has more definition, as you can see, and it's no longer just, like this. It's no longer just fading away. But again, I think it's too much. So we have some ways to do it. One way is to pick up the Swift loop and apply some edge loops. But if you turn on Turbo Smooth, you will see how jagged and bad the topology looks with extreme shading issues. But then we have the easier way that we have done it before, and that's to exactly just, let me change the constraint to edge. We can just apply some adjustments and put more distance between our edges. You remember the exercise in which we just did that. And now just look how different they are when I switch from one to another. Just a quick note, remember to always create a new edit poly when you want to bring some new stuff or new layers of detail on top to be able to, well, as I said, remove in case you ran into some very weird and dangerous problems. To finish with this example, I will apply another edge loop in the middle one, and as you can see, there's no more, as I switch, you see it's more defined, it has more sharpness, and there's no much just fading away present in here. And then let's go to the other example. You see how there are little holes and then another detail just like before in here. So I bring this base mesh up. The first thing to do is to make the holes on the surface. Here of course I created a new edit poly. I want to add the small details in here, so I'm adding here some more geometry to work with, like this. As I told you that our goal is to create the holes in here, let me just add this edge. So notice the order to which I'm selecting these vertices. It's so important to select like this one, this one, this one, and also this one, and finally that, and let me select that, and select the connect command. As you see, now we have the geometry to be able to create the n-gon that we want. And then, the second step is to select the unnecessary edges and deselect the necessary ones, and then control remove them. Also, I believe there's also another loop here to be cleared. Okay, yes. And then the next step is to select the middle vertices and chamfer them. As you can see, let me turn down the radius and create the safe n-gon that we want. You remember the safe n-gon should be a little bit bigger than what we originally planned, and then I inset a little bit inside for the main thing, and then it's going to be just extruding and beveling and going inside and adding layers and layers of detail, as I'm doing right now. Add another bevel or inset in this time. Just like this. Let us now see what has happened with Turbo Smooth. You see now we have the details that we originally planned, although they may not look like exactly right like the reference, but well, they are easily adjustable and we can do work on them more if we want to. But now, let me tell you something. You should pay attention that we always, in this case scenarios where we have to add layers of details, we should preserve the overall sharpening of the corner edges to the last step, because we might run into problems. So now I will start to add the other detail first, and then at last preserve the sharpenings of adding the edge loops to the corner parts in the last parts. So just like the last example, I will now add an edge loop to maintain. Let me just adjust it a little bit. So let me now add another edge loop here and one here to why? To exactly limit or maintain the place of our interest. And then for this instance, I'm going to actually do something new. I'm going to detach. Let me just find it. I'm going to detach our edges in our mesh from the other parts. Let me just repeat the problem. Make sure to uncheck the detach to clone, because we want this to be cut away from the geometry. We do not want an instance copy from it. So I initially plan to extrude these edges so that I have a platform, and I will then bring the upper part and put it on top of the platform. So let me select again the extrude operation, like this, to create the platform that I talked about. Now you see there are some vertices to be target welded on top so that we have one clear face. Exactly, I do the same thing here and connect the two vertices to the top, and then I have to repeat exactly the same process for this one. I extrude, let me change the amount of extrusion, so just like this, and again pick up the target weld tool and connect this to that one, and also on the other side in the wireframe mode, and be sure to just delete the diagonal edges. Now see, it's going to just snap to the place and stick tightly where we want. Now you remember how we used target weld tool to tweak some vertices, right? So now we have to again adjust these vertices and put them right on top of another to be a perfect match as we want. And now, after that we have done our adjustments, it's time to first delete the unnecessary edges that we added when we wanted to detach our surface from the model. Then add diagonal edges and hit the connect command, and then start to remove the unnecessary edge loops, or better say edges, that we added originally here. And then this is time to see how soft they are. And to make them sharpened, as I said, this is the last steps of modeling in this case, is because we wouldn't want to deal with some extra edges alongside the corners when we want to add new details. Now, as we add edge loops on the corners, on different corners, different sides, we will see how it will turn out to be more sharper. Also, I can, for example, like this, I can put one here and you can see how it became so sharp. And exactly the same thing goes for the other part that we just detached. Just quickly and relevantly place edge loops alongside all of the corners to finally get the mesh that we exactly want based on our reference. As you can see, this is kind of good, but we still haven't added the main edge loops in the corners of the model. So by using the techniques we learned before, we can connect these vertices and just make things right according to the topology and don't get bad results. And for this, for example, I can just put my constraints to edges and just a little bit make them closer to the near corner, and same thing can be applied there. And also I can manually cut this vertex to that and just pick up my target weld tool and connect these edges, these vertices to each other. Or I can just manually pick up again my cut tool and set up the median point, and then pick up the target weld tool and connect both to that point in the middle, and then just keep adding vertices like here. And then we have two edges that we should select and hit connect for them to be connected properly. And also about here, this process is, well, the thing that we are familiar with enough. And as you can see, we are done with this example. For now, let me bring up the robotic arm and show you the next example that we are working to work with. You see here, which is extruded, sticking out like a pipe serving as a cable entrance. We're going to actually be modeling this in a technique that involves more manual tweaking, a technique that will allow you to think and consider the foundations of topology and understand how things actually work while we want to model this. Not necessarily a technique that will get the job done. We will be using both the commands that are familiar with and also some new ones that I'll be showing you. So again, we have our base mesh here, and then the first thing to do right now is to just make an instance copy make sure that it's set to instant, and just rotate it a little bit. I want to rotate it to get something kind of a flat and straight surface on top of our mesh, because we want to actually make it more easier to place and extrude on top of the mesh. Otherwise it will be a little bit more tricky, a little bit more challenging. For example, now if I just create my Engon, set it to 8 sides, you see how straightly it stands on top of the mesh. If I just move it here, it stands straight on top of the surface, also corresponding to the world coordinations. So whenever we want to move it or whenever we want to apply details, we can just work normally and everything will just be in line with our surface. So let us observe what we have here and rotate to get it right, to make this a kind of a flat surface on top of it, and then adjust the Engon. And to make things even easier, we can just use our snap tool and just move our Engon and snap them to one vertex that we want. If we want to be on top of this one, for example, or that one. And then I just move it slightly towards the top and select the Engon, and now I will use the shell command to give it some depth or to make it look like it's a shape and no longer just a circle line, and so that I make an edit poly from it like this and it looks just like a regular poly shape. Then for the other side that rests on the surface, I copy and just rotate it and move it down a little bit, overlapping in the surface. So now I want to attach, I want to attach these two Engons together using attach, and then I will want to select the upper Engon, deselect the edge on that, and just align eyeballing this in relation to that. And I select the two faces and select the bridge modifier so that they will just connect to each other like this. But now we do not want this to be straight and exact, right? So we add some edge loops in the middle, and then now I want to manually adjust some edges and get the result that we had in the reference. So I just continue tweaking and continue moving vertices around, moving edges around until I feel that it's close enough to our reference. Now there's one view that we should consider it too and adjust based on that, and this is particularly this front view where we have to adjust these two vertices or even more to preserve the circular shape of our model. So still in this point, we do not necessarily concern ourselves with the topology on the model, on the base mesh that we originally have, which is going to be our surface. We just continue with our n-gon that we added and just concern to make that according to our desire. And then we will be getting into those parts and just align everything up and connect them all together. So still now I'm adjusting the vertices so that I can attach this part that we are modeling to the surface underneath. So we have to just put the proper distance between the vertices for them to get a nice shading and not be distorted or jagged and all. I rotate around the object. Now I believe we have to continue to make things right on the surface now. We should be careful about which edges we select and how we actually move them accordingly, because this process might just ruin our original shape. So we should be careful editing this geometry. So you see the middle edge that is going all across it. We should also change this accordingly because we want to make them be able to connect to each other. And so for the remaining vertices, if you take a look around our n-gon, we see that we have to add these edge loops to be able to connect them to each other. Here, we are not able to do what we just did on the other side because our face has more than 4 edges, and to compromise, I just connect them manually for now, just like this. And now it's finally time to start the attaching process of these two details. Let me just adjust it real quick to apply the finer details and rotate it maybe a little bit like this. So now I will take a copy from our model here like this and make sure to set it to copy mode and not instance mode. And for now, let's delete that one and focus on the first step. So here it's going to be a 2-process thing. In compound object, I select Pro Cutter, and then I select Pick Stock Object and select our detail. And now our object has been cut according to the base mesh that we had. So let me just delete the previous one. And notice that we, in the last example, used the base mesh as the start. And now I select our detail as the start. Use the pick stock object and select our base mesh and see how exactly the opposite has happened. Now, I just have to adjust it and move this close to the detail, and then convert it to a new edit poly, and make sure to get rid of the face here just like this. And then I'll bring up the detail and snap it like this to the place where it belongs. Now that we have our detail on the surface, I select the faces around and detach them from the mesh right here, because now I want to focus connecting the edges, or better say connecting the vertices of the surface with our detail to be, let me first delete this face. So I was saying that now I want to focus on adjusting the vertices, make sure everything is connected and welded together, and things like this. So one by one, I will target weld these vertices that are floating to the vertices of our detail, but make sure to only change the vertices which are around our detail and not the vertices on the corners and edges on the corners, because we'll be getting into some problems. As I told you, we should not redefine or adjust the edges so that in a way our model changes, because, well, it's obvious we'll be getting into some problems that will be hard to adjust. And now you can see still we have some vertices that haven't been welded together. Using weld command, I can fix these shading issues, and just like that, our first step is kind of done. We have attached successfully our detail to or on top of the surface. A quick reminder, I told you to be sure to get an instance from your model, and that means you shouldn't have collapsed your geometry because it would otherwise interfere with your model. So, and as I told you, you shouldn't have applied any type of adjustments to the corner of your mesh. And now we can just select those same faces and delete them and pick up this geometry and just snap it to the place. And you gotta make sure that you attach the base mesh to the detail and not vice versa, otherwise it will just exit the instance mode. So, and the next step after the two steps that we have done, we should select all the surrounding edges and select control vertex so that it transfers to the vertices, and just weld them together. So now if I turn on turbo smooth, you can see how well it has joined the detail and the base mesh together. And now I just added a cap here. And for example, I can give it an instance and I can adjust it like this and repeat the process. And I can just select the extrude to give it some more details. I repeat the process, give it another inset, and then extrude, and just play with it to get what I feel like it will be suitable for this demonstration, like this. And now, as you can see, we have created the detail and then attached it to the surface and made everything clear, everything good. And now the last step, as you can remember, I said will be to just use the Swift loop and add the sharpness that we would like to have and just edit the places where need to be manually cut, as I just did. And this is basically the instruction and order in which we have to do things in Hardsurface design. So you might wonder why I have preserved a copy from the detail that we just made. And notice that I have used the same detail over here. So in fact, I just made one copy of the detail and just reused it to save time and save efforts like this.